That's fine. No, it's okay. If you do. Okay, before I forget my own students. Good morning, everybody. Hey, Abangis are online. Good morning, everybody. Morning. Me right? In I was new, you know. I want to take the weekend was good. Huh? Bafana won. Oh, did you bet? Yeah? Now stop it. Okay. Oh, especially after we've done probability, ne? Yeah, you know what's the probability and you're calculating and you're checking, but what are my chances of winning? All right, good morning to those of you that are joining us online and also those that are joining us from our channel. You know that every Monday and every Wednesday, so every Monday we meet for mathematics. And this is your one lesson that you get in a week. And of course on Wednesday we meet for physical science. So today what I want us to do is optimization. Right? Was the weekend good? Huh? Too short? That will always be the case. Unless we've got a long weekend, so to speak. Okay. Right, so today I want to do optimization. Sorry, I just want to make sure I can join the lesson now. Ngizoninikeza script wenu back. What are you guys trying to say? Anwafuni? Is that what you're saying? Okay. I'm gonna give your scripts back. Hi man, but I can't get this phone on. Can someone please help me? For those of you that wrote online, guys, let's keep it down a bit. For those of you that wrote online, I have not finished with all of the scripts. I know that I still owe you guys my scripts, but I will hand your scripts back very soon. Okay, actually not very soon, today, because tomorrow I want us to have a look at those probability questions. Hey. Oh, Nkosi. Aw baba. Siyacela. Namalidapule. Right. Okay, so I want us to do optimization. Now, please, I want you to listen very carefully. And I'm going to make it very practical for you as well, so that you are able to get a sense of what to do in this section. Now, optimization is one of those sections. Honestly speaking, guys, it is an application of calculus. I just want to sit properly. It's an application of calculus. And what we are essentially just using are the principles optimization. So what we're using are the principles of finding the derivative and making it equal to 0. Now I'm going to give you a couple of rules of how we are going to go about it, right? So you'll always, in a sense, either be given a relationship of something with respect to another, right? It could be a relationship of volume in relation to length, right? It could be a relationship of speed against time. It could be a relationship of cost versus the area of a material. It really doesn't matter what it is, but the reality is that we will get always something with respect to another. Let me just make an example of velocity against time. So supposing that they'll give us, let's say, t squared minus 5t plus 4, something to that to this effect, right? So what do you have? Let's say this is an expression that gives us volume, velocity, right? Against or with respect to time. Are you guys with me now? Right. So the second thing, if I needed to derive an equation, you'll see that once you've derived an equation, you will always need to eliminate one of the variables. So there will be instances where, let's say you've got more than 2 variables, right? Not more than 2 variables, rather, you've got 2 variables. So what are we going to do? We're going to have 2 equations. Use the one, just like with simultaneous equations, right? Use the one equation to eliminate the one variable. So firstly, after deriving an equation, you are going to substitute the one equation, right? So you're going to substitute in order so that you only are left with one variable. And then the second thing is where they are going to either tell you to maximize or minimize, right? So let's say in terms of cost. Of course, whenever I am looking at cost, what am I supposed to do? I'm supposed to minimize costs, isn't it? Right? So you're finding, let's say if we are manufacturing cups, right? If I'm manufacturing cups, I'm going to make the shape of the cup such that it will give me minimum costs, right? So now, in order for me to minimize or maximize, I will always take the derivative, right? So that's taking the derivative and making the derivative equal to 0. And after that, you are then going to get whatever the variable is. Now, I don't want to kind of ruin it and say a lot. Nah? I'd rather today we spend a lot of time doing a lot of questions. Is that okay with all of you? Nah? Right. Now, there are instances. Let's say if I was talking about this equation, I said this is velocity against time. Right? if I said to you, find the velocity, if I said to you, find the initial velocity of the car, how would I find the initial velocity? Where is the initial velocity? It means I'm talking about the velocity at time 0. So sometimes just be mindful of the language that they use, right? So you'd need to be a little bit creative when you're using this section. So if I said to you, find the initial velocity, okay? Now, I want you to also note several things about the language, especially when we are dealing with examples that have to do with distance and velocity and time. So if I have the distance formula, please, I want you to remember this. Né? So if I have a distance formula, let's say that I express distance in terms of time, and I say this is going to be 3t cubed minus 4t plus 6. Right. So the derivative of distance will always be speed or velocity. So velocity or speed, so let's say this is distance in terms of time, will be the derivative with respect to time. Okay? So if I give you that distance formula and I say to you, find the initial velocity, what should you do? Right? Take the derivative, right? This time around, and take the derivative where t is equal to 0. Does that make sense? Okay? Because velocity, remember, that's the derivative. And then acceleration is the second derivative. So if I say d double dash of t, then we are talking about acceleration. Okay. Now if I asked you the question, how far will the car be after 5 seconds? Okay? How would you do that? Right. On which equation? So on which equation? Am I going to take the distance, right, and substitute 5 into it, or am I going to take the derivative and substitute 5? What's that? Think about it. I said how far, so what am I alluding to? Right, so when I say how far, I'm alluding to the fact I'm talking about distance, right? So in that case, it means I will take the distance formula and substitute time into it, right? But if I said to you, calculate the speed at 5 seconds, what do? Right? That's the derivative. Do you see? Right. So you need to always be mindful of those. So we're going to play around with a bit of some diagrams today, but we're also going to look at questions whereby we are given those, right? And the one thing that I want to also say, sometimes they give us those volume and surface area questions, right? In essence, whenever you think about volume, it doesn't matter what the shape is. So let's say, for instance, I take a cylinder. Hey guys, my cylinder is not cylindering. All right, so let's take a cylinder. Say here I've got a cylinder. Right. Now I want you guys to note, if I've got a cylinder like that, nah? All right, so in certain times they might say to me, the top is open, or they might say the top is closed. Okay? So let's say to us, maybe let's say it's got a top that is closed. So what do I know? In order for me to work out, firstly, the volume of this cylinder. Usually they might give you an equation, but how do I work out the volume of something? It will always be the area of the base multiplied by its perpendicular height. What is the base? That would be a circle, isn't it? Right? So I would need to know what is the area of my circle. So let's say I'm given a distance there, and that is r. And let's say the height of this guy is h. Are you guys with me now? Right, so when I want to find the volume of this cylinder, that will be pi r squared. What is pi r squared? That's the area of a circle, isn't it? Right? This is multiplied by its vertical height. Are you guys with me now? Right, so that's the area of the base multiplied by its perpendicular height. But I want you to note, do you see what we've got two variables there? What are the two variables? That's r and that's h as well. So they have to give me additional information that will help me to eliminate one of the variables. And usually what they might do is they might tell me that the surface area, let's say the surface area of the cylinder is, just for argument's sake, let's say 200 square meters. Right, now how is that going to help me out? I want you to note, when we are talking surface area, think about the amount of material that I'm going to make. Where's the surface area? It's this entire circumference of this thing, right? But remember, it also has a base. This would be an open cup, right? So I wouldn't count this. But if they said to me it is closed, then I need to take the area of the two circles, the one at the top, the one at the bottom, and I need to take the surface area of the circumference. Does that make sense, no? So I want you to always think about that. Now, how do we get the surface area of a circle? It would be the circumference multiplied by the height. Is there a question?
I'm sorry, sir. Can you just go back a little bit and repeat what you said about the circumference and explain the surface area of that?
The surface area. Okay. Oh, sorry, man. I forgot. So I'm showing them a cup and I'm forgetting what you guys are not seeing it. So I said with the surface area, if it is a closed cup, I'll take the area at the bottom, right? I need to take the area of the circle at the top if it is closed. Make sense? And then I will need to also take the area that is on the surroundings of this cup. Does that make sense, no? So then I would need to say, well, the surface area. Am I answering the question that you were asking, Mary Jane?
Yes, sir.
Okay, all right, awesome. So, on the surface area, so if I look at the surface area of this cylinder, okay, that would be pi r squared. And we said we are considering a closed cylinder, né? So that means I'll have pi r squared, but how many pi r squared do I have? I've got 2 because that's a closed circle, right? I mean, that's a closed top cylinder. So which means I'll have 2 multiplied by, now please I want you to note, I'm talking about the, that's pi r squared, right? Those are the 2 circles. In fact, let's do this. Plus, what else do I have? I also have the surroundings, the surface area that is surrounding the cup. So what I said in this case, this area over here. So how do I get that? This will be 2 pi r. So this will be the circumference of the circle multiplied by h. Are you guys with me now? So that will be 2 pi r multiplied by h. But what do I know? I know that this will be equal to 200. So which means I can simplify, isn't it? That's going to be 2 pi r squared plus 2 pi r h. Now, do you remember what we've got a formula for volume? Right? And our formula for volume, we've got two variables, which are r and h. So we would need to eliminate one of the variables. In this case, let's divide everything by 2. So I'm going to have 100 is going to be pi r squared plus pi r h. So let's make h the subject of the formula. So this will be 100 minus pi r squared is equals to pi r h. And if I want to make h the subject of the formula, then I can divide both sides by pi r. Remember, guys, that pi is just it's a number. It's not a variable, ne? Okay. So pi is a constant. So this is divided by pi r, and that would cancel that. So which means h would be 100 over pi r minus, so if I say pi r squared divided by pi r, that would give me just r. So that's what I have as a formula for h. Are you guys with me now? Now that I've derived a formula for h, let's call this equation 2, let's call this equation 1, right? Now what am I going to do? I'm going to say, well, for my formula for volume, so volume in terms of r would now be pi r squared into, remember I've got h now, which is going to be 100 over pi r minus r. So now, do you see what I've eliminated one of the variables, ne? Right? So now we can find a variable. We can find a formula. So that is going to be 100. If I multiply by pi r squared into the first one, the pi and the pi cancel, the r and one of the r's cancel, so I've got 100 r minus pi r cubed. So this is the expression for volume. And probably the question might say to us, find the value of r such that the volume is maximum. Okay? Now, may I ask a question? Okay? I'm going to, I didn't realize that I was actually creating a question. Let's say they say to us, find the volume or find the value of r such that the volume is maximum. All right. So, I want you to notice the structure of the question. What are we looking for? We're looking for the value of r, such that the volume is maximum. So in order for me to maximize volume, what do I need to do? Take the derivative, make it equal to 0, no? Right. If we were to draw this graph, what type of a graph would it be? What type of a graph would we be talking about here? Ungasabi, say it. It's a cubic graph. Why? The highest order of our variable is 3. Never? Right? So the highest order that I have is 3. Now, I know you want to write. Né? I want you to think about this. So since it's a cubic graph, at times you might be in a position where you find that you get 2 answers. Right? And both answers are valid. And I'm not saying this is one of those instances. Né? Right? You might find that you get 2 answers. So what happens when you get 2 answers? There has to be only one answer that will either maximize or minimize. So if they said to me maximize, and I really, guys, I want you to think about this. What would be the shape of this cubic function? Well, my cube term is negative. Are you guys with me now? My cubic term is negative. So what does this graph look like? It looks like this. When I take the derivative and make it equal to 0, in terms of the cubic function, what am I finding? I'm finding the turning point. So only one of those turning points is actually minimizing and another one is maximizing. And I want you to tell me, which one is minimizing? It's the first one. It gives me the minimum value. So if I had 2 values, let's say I find R is equal to 5 and another one says R is equal to 14. Which one am I going to consider? Right? I'm going to take 14 this time around. Why? Because this graph shows me that the bigger value for R is the one that's going to give me the maximum. Does that make sense, guys? Okay? If I'm not making sense. Yeah, your faces right now. I'm not sure. Sorry, guys. I'm trying to switch this thing on. Can someone help me? Has the Android, Mara? I've been trying to switch this thing on. Oh, there we go. No. And as you guys, okay. Right. Yeah, I'm going to show what I can be able to check the. Okay, there we go. All right. So what I was saying to you is that, so if I look at this graph, there are 2 values. If it's a cubic function, there are 2 values, minimum, and I've got maximum. And depending on the coefficient of your cube term, right? So in this case, let's try and find, let's find the value of R such that our volume is maximum. How are we going to do that? We're going to take the derivative and make it equal to 0. What is our derivative formula? So our formula was VR is equal to 100R. So this will be 100 minus 3 pi R squared. Are we together, guys? No? Right. So we've got 100 minus 3 pi R squared. But what do we know? This is equal to 0. So let's find the value for R. I'm going to take this to the other side. So I've got minus 3 pi R squared, which is equal to negative 100. Okay, negative 100. And if I divide by negative on both sides, what do I get? Divide that by negative 3. In fact, I should have divided by negative 3 pi. Divide that by negative 3 pi. Right. That cancels with that. So R would be equal to the square root. Now remember, when we take the square root, what do we say? Plus or minus, right? But you are dealing with the dimension here. If I'm looking for R, can R be negative? If I'm looking for the radius of something, okay? It can't be negative, isn't it? Okay? So in that case, I'm only going to take the positive value. At least Lana, it was easy for us to make the decision. So that would be 100 divided by 3 pi. And as a result, that would be the radius that we are going to get. Okay. Do you see the difference in the question? It said find the value of R such that the volume is maximum. Okay, you can write this down. Right. Now I want you to note the difference in the structure of the question. There's a difference when I say find the value of R such that the volume is maximum, and when I say find out or determine the maximum volume. When I say determine the maximum volume, you're taking a derivative, making it equal to 0. We find the value of R, and thereafter we are going to substitute that value back into the main equation, isn't it? Okay. Right. For a Monday, I'm saying a lot. Ne? You haven't even woken up from the weekend. Oh, the excitement. Monati. All right. I just want to make sure that for the people that are there online. Okay. For my online people, Nisase, right? Did you get a value for this? What was your value? 3.26. So which means our value for R is 3.26. Let's assume R was in meters, ne? Okay, let's keep it to meters. Yeah, we did say our area was meter squared, right? Yeah. So which means that our R would be meters. So if I say to you, determine the maximum volume, what are you going to do? Substitute R back into the main equation, isn't it? So I'm going to say V of 3.26. And so all that you're simply going to do is go to the main equation. So that was 100R. So 100 multiplied by 3.26 minus pi, pi R cubed. Minus pi into 3.26 cubed. So that would be the maximum volume. Are we all good? Okay. Right. I didn't realize I was creating a question. Bengzamugun illustrator or something, but it ended up becoming a question. Eh? All right. So I want us to delve into some examples together. All right, and let's see how we are going to apply this. All right, can we go into it, guys? Okay. Right, I've taken these from past exam question papers. Please, if you are not able to see it clearly, I'm going to read it out. So they say to us, the number of molecules of a certain drug in the bloodstream, right, T hours after it had been taken, is represented by the equation MT, right, that is M of T, which is equals to minus, otherwise MT is going to sue us when he hears we are using his name. Minus T cubed, right, plus 3T squared, plus 22, right. Now notice, what did they do? That was random. But at least uzojabula ukuthi siyamfeature ku-maths, yabo? So he's relevant. Okay. Right. So T would be any value that is between 0 and 10. Right? So what are they trying to do? They're trying to caution us with, okay, whatever solution that we get, we must only consider values between those boundaries, between those restrictions. Are we together? Right. Okay, let's go for it. So they're talking about a drug in the bloodstream, right? So they say determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. So T is in hours, isn't it? Right. So how many molecules are there after, as Enigma would say, 3 minutes? Okay, after 3 hours, what would we get? So we go to our main equation, t cubed plus 3t squared plus 72t. But what do we know in this case? We are looking for the number of molecules after 3 hours. So in that case, we are simply going to take that and substitute 3 into it. Dang it? Okay, right. So that's going to be minus 3 cubed plus 3 times 3 squared plus 72 times 3. Help me out with an answer there. 1 to 16. 216. Okay, so the answer that we get is 216. And remember, we just don't give 216. In this case, what does 216 represent? Molecules, right? Right. So we've got after 3 hours, there are 216 molecules of the drug. Right? Is it right? Okay. Amelo, you look like you are very deep in thought about this. No, by drug they are not talking about the other one. Drug, I said, you know, I'm kidding. So in this case, it's whatever drug that they were using. So they say to us, determine the rate at which. Now remember, guys, the moment we use the word rate, okay, we are saying how fast. And the moment we say how fast or rate, we then need to consider what? The derivative in that case. Are you guys with me now? Right. They say determine the rate at which the molecule of the drug in the bloodstream is changing. Right? So we're looking at how fast it is changing at exactly 2 hours after the drug was taken. So they've talked about the word rate. So we know it means that they are trying to say to us, we need to find the derivative, right? But the derivative where? When t is equal to 2 hours. Making sense? Okay. So this is minus 3t squared, right? We're going to use our differentiation rule, right? So that's going to be plus 6t plus 72. But we want to find the derivative when t is equal to 2, because we want to find out how quickly is it being absorbed into the bloodstream after 2 hours, right? So in this case, that's going to be minus 3 into 2 squared plus 6 times 2 and plus 72. And that will give us 72. All right. Now, remember we are talking rate, né? How fast. So what is that? That is 72 molecules per, remember time is in terms of hours, right? So 72 molecules per hour. That means that's how fast it is actually mutating or being absorbed into the body. Okay? Makes sense, no? Right. All right? Awuboni kahle? Okay. All right. You can always come closer, ne? All right. And Buganya, welcome back to South Africa. Okay. Right. The last question They say to us, how many hours after taking the drug will the rate at which the number, how many hours? So what are we looking for? We're looking for time. Will the rate, okay, so do you see what they are giving us what? The rate, and we said the rate is the derivative. Are you guys with me now? Right. Will the rate at which the number of molecules of the drug in the bloodstream, the molecules of the drug in the bloodstream is changing be maximum? So what are we looking for in this case? We're looking for time when what? Right, when the derivative is at its maximum. When we are at our maximum, right? And remember I said to you, whenever they say to us maximum, what do we know about it? Right? We take the derivative, we make it equal to 0. Are we together, guys? Nah? Right. So they are saying to us, how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing be a maximum? So, sure. In fact, will the rate be maximum? Will the rate be maximum? Very tall, isn't it? So what are we trying to maximize this time? What are we trying to maximize? The rate. The rate. We're not trying to maximize the number of molecules. We are trying to maximize the rate. Are you guys with me? So which means I'm taking which formula tells me about the rate? It's the derivative formula. And if I'm trying, that's the derivative formula. So if I'm trying to maximize the derivative, what am I going to take? The derivative of the derivative and make it equal to 0. Does that make sense, guys? Okay, I'll say that again. What is the question? After how many hours after taking the drug will the rate at which the number of molecules of the drug in the bloodstream is changing, right, be maximum? So what do we want to maximize? Not the number of molecules. If we're trying to maximize the number of molecules, we'll take the rate and make it equal to 0, right? But what are we trying to maximize in this case? We're trying to maximize the rate. So which means I'm going to take the rate formula and find the derivative thereof and make that equal to 0. So which means, what is that? Okay, right. And I'm going to make that equal to 0. Does this make sense, guys? Okay. Minus 6t is equal to negative 6. And of course, divide both sides by negative 6. And so t is equal to, and it does make sense. Think about, when do I have the maximum number of molecules of the drugs, or of the drug? Right? I have the maximum number of molecules at the beginning, isn't it? Right? And what happens? It gets into the bloodstream and it has to try and get to the rest of the body. So which means in that first hour, that's when I am getting this guy dissolved into the bloodstream as much as possible, right? I know you can't necessarily picture this, but if you can imagine, when you're taking a pill, a drug, right? Let's say you've got a headache, you want it to work as quickly as possible, right? So what has to happen? It has to be quickly absorbed into the bloodstream. So in that first hour, I really want it to do its best. Are you guys with me now? Right. And when you think about someone who's in pain, for instance, why is it that they need to take medication regularly? Let's say you've just gone through some kind of a procedure that was painful, right? why is it that they need to take, medication regularly? Because after a while, that rate is going to drop, right? And it's going to drop significantly so that there's, the pain resurfaces again, right? So you want to take another drug, and again it becomes absorbed into the bloodstream. And guys, we are not talking about recreational drugs. We are talking good drugs, okay? Right. I'll never promote anything that is illicit on our channel, okay? Right, guys, does this make sense? See right now? Okay. Martin Kwatili, Ian Kwatisi optimization. Okay, let's try another question. Right. This time, I want you to try it out. Let's go for it. I want to see if... Right, for those of you that are on our channel, please just try to do the questions along with us. I want to... and if you're quickly able to find the answer, please just put it on the comment section so that I will be able to see that. This is what will be happening at the end of the year, né? After you guys write the exam. So Mama, like I'm really worried, yes? Do you need to be wearing glasses? I think you should, yes? Yeah, the way you squint your eyes. It's a little bit for namhlanje, ne? Uthi ukhumbulile futhi dala wathi ukhuluma nawe. Akela kwenza. Askis. Eshage khona umuntu esingadela. Mara unabo Andrew. So we're good. Okay. Much better. I think that's accepted. Maybe we might need to go for that eye examination. Unless it's over phone and so, were you the educator? So remember, TT is in days, right? So if I say 3 days, so this is the number of schools. This is your father. Okay, please remember that time here is measured in terms of days, right? That's the one thing that, yes, they said T days after marking. Ne? Right, I'm going to remind you of something here. If you were to draw this as a graph, what graph would it look like? It would be a parabola, right? So which means this guy, if you think about it, it means that the number of scripts that were marked were increasing at some point, right? Then goes over now a time when there'll be a maximum. And by the way, what type of a parabola is it? It's a said parabola, right? So you reach a maximum, and after that, what happens? The number of scripts begins to decline, to decrease, okay? That is the number of scripts per day. Remember, the number of scripts per day is the derivative. Does that make sense, ne? The number of scripts is the formula. The number of scripts per day is the derivative. Make sense? Okay. I'm giving you lots of clues now. So we're comparing it with 500. That's a question. So which means we need to be able to find the number of scripts that were marked in total, right? Yes. Of scripts that were marked in 10 days. If they are less than 500, then it means that we have reached the quota, right? What's your My question is okay. And this is the part you need to be thinking about. What gives us the number of steps? Is it the main equation? Is it the relative? Is it the what gives us the number of steps? How then do I get the number of what do you guys get? First, yes, okay, so I think this one wasn't yet issued. 10.2. Why did you take the remember, we did say something in the previous question, but you realized we took the second. So it's only the language. So what take maximum number of statements? Okay. Yeah, so maximum number of cases, 1 right? So in that case, it means that we are trying to number of states. Yeah, it's like hidden lingual. Some is like hidden but we'll get to that in just a to be quite honest with you guys, as easy as this question seems, it's not really the easiest. Ne? Okay. Right, and please, I want you to listen very carefully. Right. For those of you that are online, please just also pay attention. So they said to us, the number of scripts marked, right, by a certain marker is checked at the marking center T days after marking started, which is represented by the function S of t, which is minus 3t squared, right, plus 30t, bless you. Right, so which means, how many scripts are we, how many days are we going to be marking for? Right, we're going to be marking for 10 days, right? Starting from day number 1, all the way up until day number 10. Now, they say where S of t is measured by what? Scripts per day. Are you guys with me now? So please be mindful of that. What is S of t? Scripts per day. So which means when I plug in on a certain day, I am getting the scripts for that day. Do you get it? So if I wanted to find out at day 1, how many scripts did I mark at day 1? I'm going to plug in 1, but what am I getting? Scripts for day 1. If I'm going to plug in on day 2, what am I getting? Not AMA scripts for day 1 and 2, I'm getting only for day 2. Does that make sense, guys? Okay? I hope that's clear, guys. So you notice when they give you a question, look at the language that they are giving us. Okay, now they said to us, determine the number of scripts that were marked by the marker on the 3rd day. So which means on the 3rd day, we are getting only the scripts for the 3rd day. Does that make sense, no? Right. So then we said, okay, for this one, I think most of you got it, even though minus 3t squared plus 30t. And then we're getting the number of scripts. Now notice this is on the 3rd day, right? Not after 3 days. Do you get the language? Right? We're not getting the number of scripts after 3 days. We're getting, if I said after 3 days, it means cumulatively, I want to know how many scripts I marked in day 1 plus 2 plus day 3. Does that make sense? There's a difference there. But I'm getting scripts on the 3rd day. So, and I'm getting somewhere with this. I keep mentioning this because I want you to get it in terms of the last question, because I saw many of you were having a challenge on that one. So that's minus 3 times 3 squared plus 30 times 3. And what did you guys get? What's that? 63. Okay. So on day number 3, I marked 63 scripts. I got 63 scripts. Good? Okay. Right. Let's go to the next one. On which day will the marker reach a maximum number of scripts marked per day? So what am I trying to maximize in that case? What am I trying to maximize? Right? The number of scripts per day, isn't it? How do I maximize that? So S prime. So take the derivative, because the derivative gives me the rate at which I'm marking per day. Does that make sense? No? Right, so S prime, that's going to be minus 60. Right? By the way, I've assumed that everybody understands this. So remember, we use the differentiation rule, right? 2 times negative 3 will give us minus 6, right? But we subtract 1 from that, so that gives us minus 6t. And we've got a 1 there, that's 1 multiplied by 30. That gives us 30. And if we say minus 1, that gives us t to the power 0, which is 1. And that's why we end up with just the 30. Okay, right. Lorraine, are you still with us? Okay. For sure.
No, I'm just trying to make sense of the question.
Of the question,
Yeah.
Okay. And it makes better sense when you look outside the window.
No.
Gaze into the blue sky. Okay, so minus 60 is equals to negative 30. And so what did you guys get for t? On which day did the marker get the maximum number of scripts? Okay. 5th day, or day number 5. Does that make sense, guys? All right. So if we were looking at getting the number of scripts, this is what it looks like. So on day 1, he was still trying to get into the groove. On day 2, on day 3, and then on day 4, he's now getting into the rhythm. On day 5, he's now marking many scripts in a day, right? That's the maximum. But what happens? He starts getting tired, right? Day 6, that's when the fatigue is now setting in. On day 7, even worse. And by the way, this is truly what happens when you are marking scripts, okay? On the days la usase fresh corner, you're able to get many scripts because number 1, you are still very fresh, but you still haven't familiarized yourself to the questions, right? On day number 4, you are like flowing because you even know the questions off by heart. Ne? Okay, right. 10.3. Bengenikeza nje information extra. I want and why sometimes for some people it might be wise for them to go and ask for a remark. Because maybe I marked your script on day number 7. Yabo? And on day number 7, honestly, I mean, you've seen this, guys. I've given you your scripts back, right? And it depends on when I marked it. You'll find sometimes I've missed some marks somewhere there, right? It happens. We're human. It's not a computer that's marking. I'm telling you the truth, right? At the end of the day, that's what happens. Now, the last question, very, very interesting. I wonder if the person who was who designed this question thought about this, né? But I want you to think about it. They say the total number of scripts that a marker had to mark, right, for the 10 days was 500. Did the marker reach the quota? Support your answer with calculations. I'm not sure why they gave this 2 marks. I'm not sure. How would I be able to get the number of scripts, guys? Now, you guys have not done integration, right? I would have done integration. But you haven't done that, isn't it? Anas, whether you've done integration or not. So how would I be able to get the number of scripts? I need to find out on day number 1, on day number 2, on day number 3, on day number 4, right? Right?
Yes.
Okay? And up until I get to day number 10. Are you guys with me now? Right, so let's do that quickly. S1. How many scripts did you mark on
27.
So that's 3, that's 1 squared plus 30 times 1. So we got 27 scripts. On number 2, how many scripts? Okay. On day number 3, you remember we already have day number 3, right? Day number 3, 63 scripts. On day number 4, 72. Okay, right. Day number 5, 75. You remember, they said to me that's the maximum number of scripts that I'm going to get. Okay, now, if we add all of those up, what do we get till day number 5? If we add those numbers, huh? What is it? How, guys, give me the number. 285. Okay, so if I added S1 plus S2 all the way up until S5. Okay. So you said what number am I getting? 285. Okay. What do you think might happen on the days that are to follow? The number of scripts is decreasing, right? And chances are that we will get, remember, you said to me this is a parabola. And I already know my turning point is at 5. So this might be a mirror of that. Never? So on day number 6, but let's see. Let's see if that's really the case. On day number 6. Yeah, what? Man. This AI stuff is not. So on day number 6, what's happening? 72. What do you think on day number 7 it's going to be? 63. Yeah, what? On day number 8? 48. On day number 9? On day number 9? Is it 27? And then on day number 10? 0. They're not. So he decided to be absent on day number 10. It is 0, no? Okay. So which means if I were drawing this as a parabola, this parabola looks like this. Are you guys with me? Right. We found up until the maximum, we had found 200 and... You said 275? 85. All right, what would be the number of scripts in total? 495. Excuse me? 495. So apparently the number of scripts in total would be 495. Did they meet the quota? No. So the total number of scripts . Now, I don't know, guys. I don't know. Could we? Nah, there was no way. There's no way. I'm trying to think, Uguti, could we have modeled this as a sequence, right? And what type of a sequence would it be? It would actually be a quadratic sequence. Yeah, it would be a quadratic sequence. But still, with the quadratic sequence, there's no formula for the sum. Yeah, we don't. Okay? So it would have been better if they had, I don't know why they thought this is worth 2 marks, but nonetheless, this is how you would go about answering this question. So you'd add all of those up. Apparently it gives you, the total number is 495, which is less than 500. So therefore, they did not reach the quota. Okay, right. I'm happy to have given you questions that are around the rate and those kind of stuff. Né? I want us, in conclusion, to just look at one more question. This time around, this is where we started. Nyakumbul? They say to us we've got the radius of the base of a cylindrical cold drink can, which is x centimeters, and its volume is 440 cubic centimeters, right? They've given you the formulae for area, right? For circumference, as well as for volume. They say determine the height of the can in terms of x. Right, the height of the can in terms of x. How do we get that? So what did they give you this time around? They gave you volume, no? So which means in order for us to express or to find that equation, we'll have to take volume. So we'll say volume would be equal to, that's pi r squared. You remember when I said to you, that's the area of the base multiplied by the height. But what is our volume equal to? That's 440, right? And what are we meant to do? To make h the subject of the formula. So we're going to divide by h. Sorry, not divide by h, rather. Divide by pi r squared. So h is 440 divided by pi r squared. That is the formula for h. And I can already anticipate what's going to happen in the next formula. In the next question. We're probably going to have to substitute that value that, that we had for h into another equation, right? So that we isolate one of the variables. We've got two variables in this case, which are r as well as h. There's a question. Yes, ma'am. Excuse me? Oh, sorry. They said determine the height of the can in terms of x. Sorry, I forgot. They said the radius of the cylinder. So our radius is x. So this is x squared. Thank you for that. Né? So our radius is x squared. So if this is our cylinder, there's our can. Okay. So I know that the radius from the center is given in terms of x, and we've got a height which is h. Are we together, guys? Nah? Right. Okay, let's go for the next one. They say show that the area of the material needed to manufacture the can is given by 2 pi x squared plus 880 over x. Please go for that quickly. Remember, I showed you a for surface area, né? Right? We are talking about a can, and they told us that we know what a can should look like, isn't it? Is it closed top or open? Should be closed, right? was an open, that's a very good question. So if it was an open can, which means must consider a surface area, we're only going to consider only one of the circles, right? The one underneath at the base, right? And the one around the can, yeah. Okay. The circumference here corner. Right? Even when I give you in future on Bonisa examples where we are looking at a rectangular prism, right? So now you need to be mindful with whether is it open at the top or when you're done with that, please go for 8.3. Got it? It's not got it. Okay. But you get it. We've got the two circles. We've got the circumference. So you have to use your imagination. Because we're not talking about a cup, we're talking about a can. So if you think of a can that has something close in it, usually, if you're going to manufacture, you never buy a can of baked beans. Right? If it has to be a can, we're assuming in this case that it must be placed at the top. Okay. So even though Mama Shomo necessarily the question, it's kind of implicit in a sense. Okay, they imply it. Okay. Oh, okay. Father, good dictionary. Good vocabulary. Okay, anyone who's got it online? 8.282. No, I'm not charging you. I'm charging you. Right, we need to conclude. I'm loving what I'm seeing. So it's a good thing Uti, that coincidence happened at the beginning, where I was trying to explain something, but I ended up presenting it as a question. Okay, so they say to us, show that the area of the material to manufacture the can is 2 pi x squared plus 880 over x. So guys, I want you to consider, remember we are considering that this is a can. So it has to be closed on both ends, right? Right? So it's closed on this end, it's closed on that end. So if I were to talk about the surface area in terms of x, this would be the two circles, 2 times pi x squared. I need to see the radius is x, ne? This is plus the circumference multiplied by the height, okay? So the circumference is 2 pi r, or rather 2 pi x multiplied by h. So let's try and, so that's 2 pi x squared multiplied by 2 pi x into, but we already have a formula for h, that's 440 divided by pi x squared. Right. So what's going to happen here? The pi will cancel with the pi. One of the x's will cancel with one of the x's in the denominator. And 2 multiplied by the 440. So we end up with 2 pi x squared plus 880, right, divided by x. So this is the surface area formula in terms of x. And finally, what did they want? They say determine the value of x, correct to 2 decimal places, to 2 decimals, for which the least amount of material. Nyabona, what are we trying to do this time? We're trying to minimize, right? We're trying to minimize. So for which the least amount of material is needed to manufacture such a can. So what are we going to do? We're trying to minimize, so we're finding the value of x. What do? Take the derivative, right? But please keep in mind, guys, firstly, I'll need to put this in standard form. So meaning I have to remove surds. If there's a surd, yaga x, we have the variable, and I have to remove my variable in the denominator. Okay, so this is going to be plus 880 x to the power negative 1. Are we together, guys? No? Right. So what am I going to do? Take the derivative, make it equal to 0. What is my derivative? That's 2 times 2. That's 4 pi x minus 880 x minus 2. And this would be equal to 0. Okay. So 4 pi x, which is equal to 880 over x squared. That's what it means, no? So remember, x minus 2 means that it's over x squared. So what do? Cross multiply. So this will give me 4 pi x cubed is equal to 880. And I will divide both sides by 4 pi and take the cube root . Right, and that would be your value for x. Isona? Okay. Right, I'm trying to see, are there any questions? Mujanaha Tibela says, morning everyone. Morning, Mujanaha. All right. I think we are going to leave it there for today. So guys, I'm going to give you some extra stuff that you are going to do on your own. This is particularly the ones that are related to dimensions. Ne? Okay, right. Are there any questions in relation to what we've done? Nisase right? Nisase right, okay. Right, I'm going to leave it here for today. Right, thank you for joining us, guys. Ngicela nje just ukuthi silungiseni in terms of our starting time is still 8 o'clock. Ne? I see some of you in joiner online have a culture of coming into the session late. Please, let's fix that, okay? Right. But for those of you that are joining us on our YouTube channel, thank you for being with us, and we will see you again next Monday for maths. For those that are doing science, we'll come back again on Wednesday. All right, ngizonibona in the next 30 minutes for those that will be with me for science. Sharp, sharp. Jovite.